As like others said, like RISC-V is basically open source ISA. Like for example, now we have like x86 and ARM, they're all proprietary, so we need the open source version. And so I'm from ExpressVPN, and for me, like the most powerful feature of RISC-V is its open source nature. Not only because of its open source nature, I think the most important part is like it promotes an environment that all others people can collaborate on. For example, you get like other proprietary ISA. The environment is different because they are not like promoting open source mentality. But with RISC-V is different. It's built from ground up open source. So everyone has the mentality that we can collaborate with each other and improve on stuff. I think this is the most important part of RISC-V. So first of all, its permissive license is also very valuable to businesses because for other proprietary ISA, it's much costly. You need to pay a hefty license fee to just build the products. So if you are like building an orange pie, right? You don't need to give any cost, and this alone, low cost, is already a pretty big benefit to all other businesses. Because for most businesses, they don't care about like how the tech is run, right? For a lot of businesses, they just care like how cheap can I get it for, right? How can I like reduce the cost?
What's the price of this one?
It depends on where you buy it. I think like around.
From you, buy from you.
From me, I don't make those. But like it's cheaper than a Raspberry Pi. At least it's cheaper than Raspberry Pi. And this alone is already why a lot of businesses is looking at this. It's because of the low cost. And if we want to like deploy RISC-V on like IoT devices, this will be the biggest benefit. It's cheap. It's so easy to sell to businesses. This is cheap and it works. So also it's modular. This one is like, I think this is catered to like more advanced businesses. If the business want high speed, right? Now we have low cost, but how about speed? You can like implement your own extension to RISC-V, and that's very good for businesses. A lot of businesses rely on performance, and they can make their own ISA and implement it if they want, or outsource it if they want. And this is very beneficial to a lot of businesses. It's easy to sell basically, because if RISC-V wants adoption, you need to convince the businesses to adopt them, right? These are all very good points to adopt them. So I'm a software guy. I don't actually like design chips. So I basically migrate things to RISC-V. I'm basically I've just finished migrating the lightweight protocol, the VPN protocol, to RISC-V, and it works flawlessly. But there's a lot of pain points when I'm migrating things to RISC-V. Because if you talk to like a lot of business owners, like why? Okay, now I know that the benefit of RISC-V, but how hard it is to get my product on RISC-V. Most of them like they care more about like how hard it is, the cost. So for now, the ecosystem is growing. It's been very good, but there's still like some kind of room for improvement. For example, like Node.js, one of the most popular JavaScript runtime, still doesn't officially support RISC-V. So there's some unofficial builds, but you have to like convince the business owner to use unofficial builds, which is kind of hard. Yeah, and luckily we have Ubuntu. This is very good. You can like convince a business owner like Ubuntu is already doing it. Why aren't we? It's very easy point to sell. QEMU is available, and for Rust, there's already tier 2 support, which is very good because a lot of the system programming projects out there now are being written in Rust, and having Rust adopt RISC-V is setting the pathway for RISC-V adoption worldwide. So what's my experience from for porting ExpressVPN protocol to like RISC-V? First of all, if you're doing a Rust project, lucky for you, it's basically excellent support. You just add a argument and that's it. Most of the time it should work. unless like there's some system dependency or some C++ dependency, you have to change the build flag. But for pure Rust projects, it's easy, it's fantastic. And also there's like growing communities around the world to support RISC-V. You see discussion on it like on GitHub or like other source forge. Like people are adopting to RISC-V. And I think how do we increase the adoption speed is to make the developer experience as seamless as possible. For example, in Rust, you just add a single argument. You just talk to like your business owner. Like, if I can add a single argument and port it to RISC-V and support many other devices around the world, why shouldn't the business do it, right? The business owner will be happy to see that. Also, and as the last line of defense, like you can always build from source. So this is the major part. If you have like the compiler support, you always build from source. So after like talking about the good side, how about the rough side? For now, when I was like porting the projects to RISC-V, one of the things that I noticed is the lack of Docker images online. For example, if you have ARM, if you are like migrating from x86 to ARM, there's already a lot of ARM images, ARM Docker images online. So people can just put them and like run a containerized project. But for RISC-V, it's really lacking. For example, if you just want to get a Rust Docker images, you cannot. You basically have to write your own Docker file, and it adds development time. So it's basically much harder it becomes a little bit harder to convince business owner to adopt to RISC-V because it increased the cost, right? And the benefits is now the benefit of migrating to RISC-V to most business owner now is not clear. So you don't want to have the cost too high. Also, a lot of projects now, especially the serious one, they rely on containerized builds, right? And they all rely on Docker. For example, like GitHub Runner, or you just run your own Docker server. It's all Docker. And having no RISC-V images for Docker is kind of a turn-off for a lot of developers. Secondly, a lack of remote debugging tools. For example, VS Code, right? There's still no SSH support on RISC-V. So in the first day, when I was tasked with like migrating to RISC-V, the other engineer told me like, oh, it should be easy. You just launch VS Code and SSH into it. It should like handle off the remote debugging myself. And second day, he came back to me like, oh, it doesn't work. Nothing works there. So there's no SSH. I thought SSH will work on VS Code to RISC-V, the orange part that I talked earlier. It doesn't work. Turns out VS Code actually put a binaries onto the target machine to do some kind of magic there. And the binary is obviously not compiled for RISC-V for now. So just having VS Code not having the SSH capability will be the deal breaker for a lot of business and developers. But I think this should be easy to fix because the source code is available on GitHub. You can just build it. But not having this officially supported is kind of a major turnback. And lastly, GUI applications will be much harder to migrate because for example, Qt or Tiwali, they still don't have official RISC-V support. And I guess most businesses out there, they are if they want to migrate to RISC-V, they will have to think about the cost, right? And it's really hard to justify it if you don't have the official support for it. I think this is major step. I think this should be solved if we need more adoption of RISC-V. So how's ExpressVPN doing? So basically, as I mentioned earlier, we have the Rust implementation of VPN running on RISC-V device now. The GUI is still ongoing. Just like I said, there's no official build, so I have to build it myself and work with team members. And hope that we can get it out one day. Yeah, this is the ExpressVPN side of things. So how can you prepare projects for RISC-V? So a lot of projects out there are not written in a sense, especially the lower level one. They're not designed for portability. I think this is a major problem. So if you want to build your own projects, right, write your own software, right, understand your tools. For example, evaluate your dependency. Are they do they support RISC-V, or are they easy to compile yourself? Because you have to be sure. And secondly, you have to ensure code portability, very important. For example, if you're writing inline assembly, right, or doing a lot of like hardware acceleration, then you first write a general case first. Don't just like write in an assembly for x86 and then forget about it. Like, don't do it. You write the general version first. It might be like a bit slow, but at least it works, right? So this is like very important if you want to prepare your projects for RISC-V. So yeah, also like check if your inline assembly is actually needed, because compilers are pretty good nowadays. So if you just rewrite your code just a bit, maybe the compiler can get it and do the same job or achieve the same performance without you writing any kind of inline assembly, and this should be fine. So yeah, I guess like this is the presentation. Thanks for attending.